The MSI GE75 looks like a decent gaming laptop, but how hot does it get? I'll be taking a detailed look at thermals and seeing how much we can improve performance by overclocking, undervolting, boosting power limits, and raising fan speed. I've got the GE75 8RF version here, which is the 17-inch version with an Intel i7-8750H CPU, 16GB of memory running in dual channel, and NVIDIA GTX 1070 graphics. The GE75 is also available with GTX 1060, RTX 2060, 2070, or 2080 graphics, so expect different results with different configurations. The 1070 here performs similarly to the 2060, and you can find updated pricing linked in the description. On the bottom of the laptop, there doesn't appear to be many vents for airflow, just some small cutouts above the intake fans. There were also a couple of heat pipes shared between the processor and graphics, so a change in temperature of one of these will affect the other. The MSI Dragon Center software allows you to change fan speed from auto, which was the stock default, or cooler boost mode, which basically maxes out the fan to improve cooling, and I've tested using both options. Thermal testing was completed in an ambient room temperature of 22 degrees Celsius, so expect different results in different environments. I've tested idle down the bottom of the graph, and the temperatures were okay. Gaming was tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results are from running the AIDA64 CPU stress test and Heaven GPU benchmark at the same time to fully load the system. Anytime the CPU, shown by the blue bar, was hitting 95, it was thermal throttling. Thermal throttling was still happening even with a minus 0.14 volt undervolt applied to the CPU, as listed by UV on the graph. With the Thermaltake Massive 20 cooling pad in use, it was possible to lower the CPU temperature to 88 degrees while gaming and remove thermal throttling. So despite the smaller air vents, the extra air, or simply the act of raising the laptop up off the table is helping, and the graphics also saw an 8-degree improvement here. At the top of the graph with the stress tests, the cooling pad wasn't enough to remove the thermal throttling on the CPU in this worst case scenario, though the GPU temperature did improve by 7 here. These are the average clock speeds for the same tests just shown. We can see the clock speed of both the CPU and GPU increase as the fan speed rises, as this helps reduce thermal throttling on the CPU, while GPU boost with the graphics favors cooler temperatures. We're seeing the highest clock speeds with the cooling pad in use while undervolted, as the issue here was thermal throttling on the CPU, and this helps with that. The CPU undervolt is helping the most when it comes to improving CPU clock speeds though. Despite thermal throttling taking place in almost all of these tests, our improvements mega throttle less. So we're still able to improve performance by over 500 MHz on the CPU with these modifications. These are the clock speeds I got while just running CPU only stress tests without any GPU load. With the AIDA64 stress test running, it wasn't possible to reach the full 3.9 GHz all-core turbo speed of the i7-8750H CPU, even once undervolted, due to power limit throttling. I wasn't able to boost the default 45W TDP using Intel XTU to improve this either, which is too bad. As we can see here, the temperatures for the CPU-only workloads are looking just fine. There's definitely some thermal headroom there to boost the TDP, and by extension, CPU-only performance, even if this wouldn't help in the combined CPU and GPU workloads shown earlier, as the combination results in thermal throttling on the CPU. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks here. There's no difference to the single core results, as this isn't enough load to cause any throttling. With the undervolt applied, the multi-core result was only 40 points or so behind my usual best case result from the i7-8750H. Here are the GPU-only clock speeds while under a graphical-only stress test, as well as the improvements seen by applying a manual 150 MHz overclock to the GPU core with MSI Afterburner, and this only slightly affected the temperatures, raising the average result by around 1 degree. So how do these performance boosts actually translate into games? I've tested with the exact same Windows, Nvidia, and game updates installed. The only changes were the ones listed here. Far Cry 5 was tested using the built-in benchmark at 1080p. At ultra settings, there was a 3.8% improvement to average FPS with the CPU undervolted and graphics overclocked. The 1% low rose by a much larger 9.1%, which would be due to the CPU clock speed improvement that's now possible by the throttled CPU. If you're after more gaming benchmarks with the MSI GE75, check the card in the top right where I've tested 19 different games. As for the external temperatures where you'll actually be putting your hands, at idle it was about 30 degrees, which is about average. While gaming, the center of the keyboard rises to the mid-40s. It was warm, but not hot to the touch. And then very similar results with the stress tests going. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle, it was basically silent. While gaming or under stress test with the fans on auto mode, it was fairly loud, just a little above average compared to other laptops tested. While maxing out the fans with cooler boost mode only raised them slightly higher. Auto mode was already almost reaching full speed. Not surprising given the thermal throttling on the CPU that's happening in these combined workloads. Overall, I think the MSI GE75 8RF gaming laptop is performing well once we apply some basic tweaks. However, the CPU throttling issues do negatively affect performance when under sustained load in a couple of ways. In combined CPU and GPU workloads such as gaming, the heat from both the processor and graphics seem to overwhelm the cooling solution, even with the fans at max speed, resulting in thermal throttling on the CPU, even with the CPU undervolted. Adding a cooling pad did help this in gaming. However, if the workload is intense enough, like we saw in the worst case stress test, even this isn't enough to remove thermal throttling. Otherwise, in CPU-only loads, there was the usual power limit throttling at the 45W TDP, preventing the full 3.9 GHz being reached despite there being thermal headroom available. I like what Asus did in the newest SCAR 2. While it did still have a 45W TDP in combined CPU and GPU load, under CPU-only load it was capable of running higher at 62 watts, allowing it to perform better. Yes, it does run warmer as a result. However, in a CPU-only workload, it's still far from thermal throttling. And I think this would have been a better option for MSI to implement, rather than just hard capping it to 45 watts regardless of the type of load. Hopefully we see this in a future BIOS update. It is worth remembering this is the GTX model of GE75, so it's a generation behind the newer RTX models. I won't know if this has been improved in the newer models until I get one for testing. I did notice the battery drain while plugged into the wall with the 180W power brick that came with the review unit. However, the MSI website notes that this model comes with a 230W brick, so I'm guessing the review unit just got the power brick mixed up over time. With the correct brick, this shouldn't be an issue. I don't believe this caused performance problems in my testing. I only saw the expected 45W TDP limit on the CPU and the battery drain seemed slow. And there was no current limit throttling, something I usually see when the power brick is obviously too small. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results, primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements. So don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. Undervolting and raising the fan speed is much easier for most people to do, and as we've seen, it did improve performance in the GE75 gaming laptop. A cooling pad can help out too. As thermal throttling is the enemy here, anything we can do to raise the laptop up to improve airflow and otherwise blow in additional air should assist. Let me know how much of a performance boost you found by undervolting your hardware, and what you thought of the improvements here. And of course, don't forget to subscribe for the full review of the MSI GE75 gaming laptop, as well as future thermal testing videos like this one.